Welcome to the deep dive. We're jumping straight into a really critical area today. Enterprise risk assessment in cybersecurity.
Yeah, absolutely essential stuff.
It's so much more than just the technical side, like scanning for viruses. It's really about understanding the business itself, the context, and what happens if, something actually goes wrong.
Exactly. And the sources we've got lined up for this deep dive, they give us some really interesting different angles on it.
Like what?
Well, we've got everything from this really high-level 360-degree perspective on security posture down to the nitty-gritty of, say, penetration testing and incident response planning.
Okay.
And importantly, how internal audit fits into the puzzle, how they oversee things.
Right. So our mission today is pretty clear then. We want to pull out the most crucial bits from all these different sources.
Yep. The goal is to help you understand how organizations can really effectively find, assess, and ultimately manage their cyber risks.
Okay, let's do it.
And just before we jump in, we really want to thank our sponsor, www.cisomarketplace.services.
Absolutely. Their support makes these kinds of deep dives possible. Thanks.
Okay, first up, Periton Labs and their 360-degree enterprise risk assessment.
That 360-degree view, what's the core idea there? What should we really grasp?
The big thing, I think, is their focus on the whole picture. It's not just looking at tech in isolation.
So like everything together.
Yeah, exactly. They stress looking at the critical business processes, the systems they run on, the threat landscape, which is always changing, right? And then the classic elements, people, process, technology, and the underlying infrastructure. It's about seeing how they all interconnect.
So you can see how a problem in one spot might ripple outwards.
Right.
What's the ultimate aim of taking such a wide view?
The main goal is to get a super clear snapshot of where the organization stands right now, security-wise.
Okay, the current state.
Right. Then define where they want to be the desired, more secure state, and then, crucially, build a practical roadmap to bridge that gap. How do we actually get there?
That sounds like it needs to be flexible. I mean, they mentioned it being used by utilities, healthcare, finance, government. That's a huge range of different organizations.
It is a huge range, and that just underscores that, cyber risk is basically everywhere in critical sectors.
Makes sense.
And their process, it's quite systematic. Starts with identifying risks, assessing them, then managing them.
Standard risk management flow.
Pretty much. But then they get specific, like pinpointing and prioritizing risk scenarios, thinking about the potential for loss, then profiling the current setup, defining that target state, and figuring out where the smart security investments should go.
Okay, let's unpack those analysis areas they mentioned. It seems really comprehensive.
Oh, they definitely try to cover the bases. It starts with criticality analysis.
Which means?
Basically, understanding the business impact if things go wrong, looking at supply chain dependencies, disaster recovery readiness, compliance stuff.
Even the cost of not complying.
Yeah, exactly. Yeah. That's a big one. Then there's threat analysis, where are threats coming from, what kind of attacks might happen, using threat intel, and social engineering assessments.
Social engineering. That feels like the constant thorn in the side, doesn't it? No matter the tech.
It really is. And the material highlights just how effective it still is. It's often that first way in for attackers.
The initial foothold.
Precisely. And it frequently leads to nasty stuff like ransomware that can just, grind everything to a halt.
Ouch. Okay, what else?
After threats, they look at people's security awareness levels, then process how good are the security programs, policies, the architecture. They even benchmark operations.
Benchmarking against what? Industry standards.
Yeah, against best practices to see how they stack up.
And then the tech piece, which I guess is what most people think of first with cybersecurity.
Right, the technology analysis. They call it a 4-quadrant vulnerability assessment and penetration testing. It's pretty broad.
4 quadrants? Like what?
Covers wireless, network, software, even embedded hardware security. Plus physical infrastructure, site assessments, resilience, geographic factors, even looking at existing controls and conditions. It's a lot.
Wow, okay. That is a mountain of data. How do they synthesize all that into an actual risk assessment?
Well, the overall risk score comes from combining a few things, the identified threats, the potential for loss, and here they look at both likelihood and impact using NIST SP 830 as a guide.
That's a well-known standard.
It is. Then they factor in the current security state and any specific vulnerabilities they found.
And I imagine the impact part varies wildly depending on the organization, right?
Yeah.
A hospital's worst-case scenario is different from a retailer's.
Totally. They mention using a custom impact scale. For critical infrastructure, Think about things like power outages, safety impacts, environmental damage, major financial loss, data breaches, customer impact, public image.
Real-world consequences.
Exactly, quantifying those.
And it's interesting they stress the adaptability of it all. It's not just a rigid checklist.
That's key. They say it can be tailored to different standards, regulations, and importantly, different budgets. And they specifically call out data security as its own sort of domain, which makes sense given how vital data is now.
Okay, that 360 view feels like a really solid, holistic starting point. Now let's zoom in a bit with the CREST Guide to Penetration Testing. What exactly is pen testing in this context?
Think of it like hiring ethical hackers to simulate an attack.
Okay.
The whole point is to actively try and break through the security controls, find those exploitable weaknesses, and CREST really emphasizes the manual aspect, skilled testers going beyond just running automated scanners.
So it's like kicking the tires on your security system before the actual criminals do.
That's a great analogy, yeah.
Yeah.
And the payoff can be pretty big. It can actually help reduce IT costs long-term by preventing breaches. Well, fixing vulnerabilities before they're exploited is usually cheaper than cleaning up a massive breach. It also improves the overall technical security, builds confidence that your defenses work, and just generally raises awareness about technical controls.
But I guess it's not a magic bullet, right? I assume CREST mentions limitations.
Oh, for sure. You have to understand its limits. It's always scope specific. It only tests what you agree to test.
Right.
It's mainly technical, so it might miss things like, say, insider threats or weaknesses in physical security procedures. It's also just a snapshot in time. Security postures change.
And legal stuff could limit it too.
Yeah, legal or commercial factors might put some systems off limits, and, no single test will ever find every single flaw. That's just unrealistic.
So where does pen testing fit into the bigger security picture? It sounds like one tool in the toolbox.
Definitely. The guide sees it as a key part of a wider technical security assurance framework. It's not a one-and-done thing. It's part of an ongoing cycle of testing and improving.
So if an organization wants to set up a good pen testing program, what does CREST say they need to focus on?
Several key things. First, clear governance. Who's in charge? What are the rules? Then really understanding why you're testing.
The drivers.
Exactly. Is it because systems are critical, sensitive data, compliance requirements, recent IT changes? You need to know the why. Then define the targets clearly, state the objectives, lay out the scope, what's in, what's out, how often, what level of disruption during testing is okay.
And picking the right testing company must be huge.
Absolutely critical. CREST stresses choosing reputable firms. Look for quality, strong ethics, competent testers, and ideally, accreditations like the ones CREST itself provides.
Makes sense. What does the actual testing process look like typically?
It's pretty structured. Starts with planning, agreeing on the test style, identifying constraints, defining scope. Management buy-in is crucial. Then using established methods, OSTM, NIST, ISAF are mentioned. Doing good research before trying to break things. Identifying vulnerabilities, attempting to exploit them, and then, very importantly, reporting.
What goes in the report?
Not just the technical findings, but the business context. What's the actual risk level?
Yeah.
And clear advice on how to fix things, the remediation steps.
And frequency. How often should this happen?
The guide is clear regularly. Because the threats are always changing, a test from 6 months ago might already be outdated. It's a necessity, not a luxury.
Any other practical points?
Yeah, they mention trying to test in an environment that's as close to live as possible and having good management controls during the test-agreed times, risk management, how to handle issues if they pop up.
And CREST itself helps ensure quality in the industry.
Yeah, by accrediting companies and individuals, they provide a level of assurance about professionalism and competence. It's valuable.
Okay, so we've got the broad view, the focused technical attack simulation. Now let's shift to internal audit's role, using the Institute of Internal Auditors perspective. Where do they fit in?
The IIA uses their 3 lines model. Internal audit is positioned firmly as the third line.
The third line of defense.
Exactly. Their job is to provide that independent assessment of cybersecurity risk. They're looking at things like, who has access to the crown jewels? What assets are the most attractive targets? Which systems would cause the most chaos if they went down? What data could cause real harm if it leaked?
So they're less in the weeds of specific vulnerabilities and more focused on the overall governance and control environment.
That's a good way to put it. They really emphasize how things like Big data, cloud, IoT, globalization, how all that has changed the game and requires a more strategic audit approach.
Makes sense.
And they talk about controls, obviously technical ones, but also contractual things, especially if you've got data stored with third parties.
Can we quickly recap those 3 lines again, just in the cyber context?
Sure. First line is management, the folks actually running the systems and implementing controls day to day.
Okay.
Second line includes functions like risk management, compliance. They develop policies, do risk assessments, gather threat intel, monitor incidents, oversee vendor security, sort of the oversight and policy function.
Got it.
And then the third line, internal audit, comes in independently to check how well the first and second lines are doing their jobs. They assess the risks and the effectiveness of the controls. They audit the auditors, in a way.
The IIA also lays out a cybersecurity risk assessment framework. What are the core parts of that?
It's got 6 main components. First, cybersecurity governance. That's all about roles, responsibilities, accountability, the strategy, risk appetite, BCDR planning, incident response, security culture, the high-level stuff.
Right, the foundation.
Then inventory of information assets. You got to know what data you have, where it is, how sensitive it is, and crack your hardware and software authorized and unauthorized.
Asset management, basically.
Yeah, yep. Third is standard security configurations, basic hygiene like patching, secure network device settings. Fourth, information access management approvals, role-based access, monitoring privileged accounts. Crucial stuff.
Definitely.
Fifth is prompt response and remediation. This covers continuous improvement, vulnerability assessments using threat intel, pen testing, incident management, data protection. And finally, number 6 is ongoing monitoring, checking access levels, vulnerability scanning, tracking incidents continuously.
That's a really solid structure for internal audit to use. And what's the CAE's, the Chief Audit Executive's ultimate responsibility here?
The CAE's big job is to give assurance to the board, tell them how well the organization is managing cyber risk, discuss risk appetite, keep them updated on threats and potential impacts. It's about elevating cyber risk to the board level.
Okay. Now, inevitably, incidents happen despite best efforts. We have this FedWeb Incident Response Plan template. What's the core purpose of having an IRP?
An IRP is basically your playbook for when things go sideways. Its main goals are protecting data and systems, getting business processes back online quickly, ensuring a consistent response, handling communications, dealing with legal issues, and coordinating with external help if needed.
It's the emergency plan. And who's usually on the team that carries this out?
The template talks about forming an incident response team, the IRT. This needs key people from different parts of the company, maybe external advisors too. Clear roles are vital, including an incident response manager to lead the charge.
And what are the typical stages when responding?
FedWeb outlines a pretty standard life cycle. Preparation first, then identification knowing you have an incident. Notification follows, then containment stop the bleeding, eradication get rid of the cause, recovery get back to normal, and finally post-incident review lessons learned.
Does the plan tell you exactly what to do for every possible attack?
No, not really. It can't. It's more of a flexible framework. It gives you the process, confirm, contain, eradicate, communicate. But the specific steps will depend entirely on the incident itself. Documentation is also stressed as super important, keeping detailed records.
And they mention exercises too. Tabletop.
Yes, absolutely crucial. Running regular exercises like tabletop simulations make sure everyone knows the plan, knows their role, and can communicate effectively under pressure. It also helps find gaps in the plan before a real crisis.
Good point. Okay, switching gears slightly. Evolve Security talks about defensive versus offensive cybersecurity. What's the basic difference?
Pretty simple, really. Offensive is proactive, finding weaknesses before the bad guys do. Defensive is reactive, building walls, detecting attacks, responding when they happen.
Can you give examples of offensive stuff?
Sure. Pen testing is a big one for networks and apps. Cloud security assessments, vulnerability scanning, wireless testing, even social engineering tests to see who clicks the dodgy link.
Right. And defense.
That's things like firewalls, employee security training, which is huge, strong access controls, remediation support after an incident, monitoring systems, building and maintaining the defenses. They actually list cloud security under both, which makes sense.
Yeah, you need to proactively secure the cloud and have ongoing defenses there. So the idea is you need both.
Exactly. Evolve argues for a balanced approach. You need offensive measures to find the holes and defensive measures to block attacks and handle breaches. One without the other isn't enough.
Okay, makes sense. Lastly, we have NewKib's red team, blue team exercise concept. This sounds more intense.
It definitely is. It's a more advanced, highly technical exercise. You've got the blue team, they're the defenders, managing the infrastructure, responding to alerts. Then the red team, they're the attackers, launching realistic, live attacks against the blue team.
Are there other teams involved besides red and blue?
Yeah, NewKib mentions a couple more. The green team builds and runs the exercise tech environment. And the yellow team are the organizers and controllers. They create the scenarios, throw in non-technical curveballs.
Non-technical curveballs. Like what?
Things like simulated media calls about a breach, urgent requests from management, legal demands, stuff to test how the blue team handles pressure beyond just the technical fight. They also simulate regular user activity and are the final refs, basically.
That sounds incredibly valuable for testing overall readiness, not just tech skills.
Hugely valuable. But as NewKib points out, it's resource intensive. You need skilled people for all the teams, the tech infrastructure. It requires significant investment, so you need to do a cost-benefit analysis beforehand.
Good point. We also briefly saw mentions of CyberClan's Security Maturity Framework and Usenix talking about threat hunting and the need for continuous learning and budget. We didn't dive super deep there, but they reinforced the idea that this is all ongoing, right?
Absolutely. Those just add weight to the idea that security assessment and defense isn't a project with an end date. It's a continuous process of learning, adapting, and investing to keep up.
Okay, so let's try and pull all this together. What are the main insights you think people should take away from this whole deep dive on risk assessment?
I think the biggest thing is that effective cyber risk assessment has to be multifaceted. You can't just do pen tests or just write policies or just rely on internal audit. It needs all those things working together.
Integrated.
Yeah, integrated. Technical evaluations need to connect to the business context. Governance needs to be strong. Incident response needs to be practiced. And you need that mix of proactive offensive thinking and solid defensive measures.
And knowing what's critical assets, data, processes that seem to come up again and again.
Definitely. Whether it's the 360 view identifying key functions or audit focusing on valuable data, you absolutely have to know what you're trying to protect and what the likely threats are. That's foundational.
And it's never done.
Never. It's an ongoing cycle. Regular testing, exercises, threat hunting, continuous learning. It's a constant process of assessment, adaptation, and improvement because the landscape just keeps shifting.
So maybe a final thought for everyone listening. How well integrated are all these different pieces, technical assessment, business context, governance, response in your organization? Are the teams talking? Is the plan alive? What steps could you take, maybe starting tomorrow, to build a more holistic, more resilient security posture? Something to think about. Definitely check out the resources we talked about if you want to dig deeper. Thanks for joining us on this deep dive